Hello! Today I've picked out a few examples for solving logarithm equations. So let's get started. In this first problem, let's locate the equal sign. So there's that. Now, the thing is you cannot have more than one logarithm on each side. So in this problem, because I have a log plus another log on the right hand side, I need to start by condensing those using properties of logarithms. So I know that if there's adding, then you multiply. So log base 2 is going to be the x times the 6. So it's log base 2 of 6x. And then this other side, this side is good to go because it only had one logarithm to begin with. So it ends up like this. Now, about half of your problems are going to end up just like this, where you have a log on each side of the equal sign. You can kind of think of it as canceling the logs. They're not really canceling, but for the left side of the equation to equal the right side, the arguments have to be equal to each other. So we do just get rid of the logarithms and set equal the x squared plus 8 equal to the 6x. And that wouldn't work if the logarithms had different bases, but they really wouldn't give you that kind of equation with what you're doing. So now I need to solve this. This is a quadratic, so I'm going to have to subtract 6x so that I bring everything to one side. So I have x squared minus 6x plus 8 equals 0. Then I need to factor my quadratic. What multiplies to 8 and adds to negative 6? Well, that's going to be negative 4 and negative 2. So I get two answers, x equals 4 and x equals 2. Now, the final thing with logarithm equations is to double check that your two solutions, or whatever your solutions are, when you plug them back in up here, for any x that's in the original problem, that it won't make the argument come out negative. And the 4 and the 2 don't do that, so they're both solutions of this. When we say argument, so if I write log of x plus 10, this x plus 10 right there, that's what's called the argument. And you're never allowed to have a negative argument. So if I did a whole bunch of work and I got x equals negative 12, well, that would not be a solution because negative 12 plus 10 comes out to negative 2, which would be a negative argument. So we might have an example like that show up. That means that there would be no solution to that problem. Okay, now back to number 2 here. Again, we can only have one logarithm per side of the equal sign, so I need to combine those two logarithms together. Now that's adding again, so again I'm going to multiply the arguments together, which is multiplying x plus 1 together with x. So I distribute the x and I get x squared plus x, and then that other side was just a 1. All right, now about the other half of your logarithm equations will be just like this, where there's only a log on one side, only a logarithm right there. In these problems, you have to rewrite this in exponential form. So it's the kind where you do 6 to the first power equals x squared plus x. So you do 6 raised to the first equals x squared plus x. So we just, going from here to here, change into exponential form. That's that key step. Okay, and then from here, it's like problem number 1. I'm ending up with a quadratic, so I need to subtract x to both sides to bring everything to the same side. So 0 equals x squared plus x minus 6. Then I need to factor. So x, what multiplies to negative 6 and adds up to 1, so that's plus 3 minus 2. And so when I solve that, I get x equals negative 3 and x equals 2. Now, negative 3 this right here is going to be a problem, because if I look back at the original, -3 plus 1 equals -2, so that's no good. It's also no good over in this other x. So we cross that out. But if I plug 2 back in, 2 plus 1 is 3, and then 2 just by itself is 2. So 2 is fine. It doesn't make any of the arguments negative. So our only answer is x equals 2. Now, in problem number 3, same thing. I locate the equals sign, which is here. And on this side, there's too many logarithms, because there's 2 instead of 1. Now this is subtraction, so I can combine by dividing. So I write log base 4, and then the division is with the arguments, so I divide 2x plus 1 divided by x minus 2. Don't write this logarithm more than once. Sometimes I see kids writing it on the top and the bottom. Well, that defeats the whole purpose. It's not the right property. It's not a property at all, and it wouldn't help you, because then you would still have 2 logarithms. So just try to remember it like that. And then equals 1. All right. So now this again has a log only on the left-hand side. So we're going to rewrite this into exponential form again. So I rewrite it as 4 to the first equals 2x plus 1 over x minus 2. Okay, now I think what makes this problem easiest for most students is if you say 4 over 1 equals 2x plus 1 over x minus 2. It's the same thing as what we had, but then you can cross multiply to go forward with your solving. So I would get 4 times x minus 2 equals 2x plus 1, because that was just times 1. So I get 4x minus 8 equals 2x plus 1. How about if I subtract 2x from both sides? So I get 2x minus 8 equals 1. Add the 8 over. So 2x equals 9. Divide by 2. So I get x equals 9 over 2, 9 halves. And that, if you double check back in the problem, plugging it back in right here or right there, neither one of those arguments will come out negative, so x equals 9 halves is our final answer. So just to kind of summarize, whenever you have a log equation, the first thing is to get it to only one log at most on each side. And you do that by condensing using the properties of logarithms. So that's step 1. And then in step 2, if you have a log on both sides, you can just think of it like canceling them. Cancel the logs and solve. Okay? And then if you have the other kind of problem where there's a log on only one side, you rewrite in exponential form and then you solve. Okay, and all of the log equations that you'll come across will really break down into those 2 main categories. And that's it.